So, hello everyone, this is Akshay, and welcome back to our channel of our GFG POTD streak of day 114. So, if you are new to this channel, please like, share, and subscribe so that we can learn, grow, and maintain a streak together. So, let us see what today's question is about, and we will see that the different if there exist different approaches or not, and we will think of it and we will solve it, right? So today's question name is primeless. It's a medium category questions, and if you have read this question and able to guess the multiple approaches as well, then it's very good. You are on a very good path. Else, let us continue our hustling and the journey ahead. So you are given the head of a linked list. You have to replace all the values of the nodes with the nearest prime number. So this question actually seems easy by reading the just first line. So if more than one prime number exists at an equal distance, choose the smallest one, right? So for 2, 6, and 10, you can say 2 is already a prime number, so it does not went left and right of it and just printed as 2. For 6, it is not prime. So what it did, it went backwards. For 6, the backward nearest prime will be 5, and for the right direction, it will be 7, right? So both have the equidistant as 1, right? So it will be, it has taken the smallest number, that is 5. Similarly for 10, the left hand side would be 7 and the right hand side would be 11. But 11 is at distance 1, so it has taken the 11, right? Okay, so that is it. Let us understand this test case on the paint and then we'll think of the solution, right? So you have this thing as 2, 6, and 10. So this is already prime, right? So what I will do that I will print it. So for 6 and 7, I'll move forward ahead and I will see that I found another prime number that is 7, and I will move leftwards and I will see that 5. But both are the distance of 1, right? So given in the question that if it is equal, then choose the smallest one. Then the smallest one will be 5 and 7 among the smallest one will be 5 among 5 and 7, right? So I will just print it as 2, 5. Similarly for 10, if you move rightwards, it would be 11, right? And if you move leftwards, it would be 7. But the distance here is 3 units, right? 10 minus 7 is 3 and 11 minus 10 is 1. So this is the smaller one, so we have to take this one, right? So it would be 11. As you can see, the answer is given as 2, 5, and 11, right? Similarly for the next example, for 1 it is 2, for 15 it's 13, for 20 it's 19. So, okay, the constraint is given as 10 power 4. 10 power 4. So the maximum time complexity we can code here is n square, right? And we can just reduce it as n root n and log n, whatever below the n square, right? So it would be like 10 power 8. So if you do not understand this 10 power 8 logic, then you must refer my time complexity video I made for you guys. It will be flashing up here now. Go visit that one video. It's of 7 to 8 minutes. Watch it on 2x speed and then come back here. Okay. So what the naive solution coming to my mind is, what can I do is that I will iterate in the list for each and every entry, right? First I will be at this point, then I will run, let's say, then I will move in the forward direction for 2. Let's say 2 do not have any violation, right? But for the 5 we have the violation, right? For the 6, actually, for the 6 we have the violation, right? So that means for this thing I have to make one while loop, or let's say for loop, while or for, you can use any loop. And for this thing moving in leftward direction, I will use one more while and for loop, right? And what I will do that here, let's say I have initialized the number x to find this thing, and I have initialized the number y to move in the rightward direction. So if I move in the leftmost direction, I will just check minus minus, and here it will do y plus plus, right? And at each and every iteration of minus minus, I will check, I will do only if that while if it is not prime, right? If it is not prime x. And similarly for if it is not prime for y, I will do y plus plus, right? So that means, and whenever I'll hit this case that I will x points to 5 and y points to 7, then I'll check with one if, that let's say this position was current, then I will just say that if current dot value minus x is greater than current dot value minus y, or y is greater than this thing, right? So I will say y minus current dot value. So if that's the case, that means this is not the nearest number compared to the y minus current dot val. So I will say I will update my current dot val as equals to y, right? Because the question said that you have to be in the nearest possible answer, right? Or in the else case, you just have to say that if both the points are equal, right? The else pass will handle this inequality less than equals to, right? And I will just say that current dot val is equals to x, right? I hope this thing is very clear, and this is very intuitive approach as well, right? But what will be the time complexity that we are iterating in this given linked list? So that will take surely O of n, and then what we are doing sub processes, that we are traversing left and right, but that left and right that we are traversing would be let's say we are just traversing, let's say in left modes we are traversing a times, and in the right modes we are traversing b times. But can't you see that this a is much smaller than Rn, is much smaller than n, right? Because you will get an eventually a prime number in left modes or right modes, and you do not have to like go for checking for 10 power 4 spaces, right? For 6 you just have to traverse just once, right? For similarly, if you take any number for 100 also, you do not have to traverse like 10 power 4 times. So it will be the worst case that you will be in 100 only, in less than 100 times only will get the answer, right? So I can say that this a and b can be considered as constant iteration, right? Constant iteration. So that time complexity will not be included, but let's say n into k, a constant here, right? And then what I am doing, that for each and every number I am checking that if it is prime or not, and for checking if it is prime or not, it takes root of n times, right? Root of n times. So I hope that you know how to check a number prime or not, right? So uh, okay, so let me explain you that thing also. That what is a prime number? That it has the factor the itself and the number one. So six is not a prime number because it has it has factors two, three, and six, more than two factors. That is the number itself and one, right? So how you can see that we can just iterate a for loop for I equals to two to I star I less than equals to n I plus plus, right? Why I'm doing this thing? Because I'm guaranteeing that if any factor is present of this six, if the factor present in 6, we will encounter at least one factor before the root n part. So if you find the root n of 6, root 6 will be nothing. If you convert into integer, it will be 2 to the 4 and 3 to the 9, so it will be, let's say, 2. So you can say that from interval 0, inclusive interval from 0 to 2, you will, if the factor exists of this number, you will find at least one factor in this interval, right? And as soon as you get any one factor which is not actually the number itself and one, you will say just return false. So I will just check if n percent I is equals to 0, then I will simply say return false. So I hope this logic is very clear to you, and let us start the coding, right? So this time complexity will take n of root n, and the maximum allowed was n square. So n root n will be definitely less than 10 per it. So if we are able to code this naive approach, this is naive approach. Naive approach, the approach which straight comes to your mind, right? So if you code this approach, then this will not get the TLE, right? So let us verify this thing and start with the coding ahead. So let us first make a prime function that will check for us that if the number is prime or not. So I will say boolean is. So let me complete this function for you guys and then we'll resume. And I highly encourage you to write this is prime function by yourself and resume the video. So I've written this prime function. It is nothing but if n is equals to 1, then return false. I have handled the two base cases, that if n is equals to 2 or 3, then return true, because these are the numbers, the lowest prime numbers 2 and 3, and then we start the iteration for rest of the numbers that is beyond 3, that is 4, 5, 6, 7, 8, and 8 and 9. And I'm using this logic that if there is a factor, if the factor exists of a particular number, then one of those factors will definitely lie in the range of 0 to square root of n, right? So let us now write our main logic in this list. So since we have to return the head of the pointer at last, so let us store the head in our current iteration, current pointer, let's say, root current is equals to head, right? And we have to traverse in the list. So I will use a while loop here, that while, let me write it, yeah, while. Also, while I'm coding it, you can make this video speed as 1.5 or 2x, yeah, because to use your efficient utilization of your time. Okay, so if current is not equals to null, while current is not equals to null, you have to keep on traversing, right? So keep on traversing, then I will say, okay, okay, then I will say that current is equals to current dot next, right? So, okay, so what would be the first base case, that if current dot val is itself is a number which is, let's say, 1, right? It will handle the case of this thing. If it is 1, then you just replace it with 2, right? And then move ahead. So I will say that current dot val is equals to 2, right? And then move ahead. Current is equals to current dot next, and then just continue from here. and we will handle the rest of the cases in the else part, let's say. So this would be my else part, right? Okay, so let us handle it now. So let's say when we move forward, we are using a variable that is int x, and currently it is pointing at current dot value. Similarly, when we are moving rightwards, let's say we have initialized a variable y, and we will say that it is currently pointing to the current dot value. That is the node which we are processing. So let us move forward now. So we have to move forward until and unless that it hits the prime number. So I will say that is prime x, right? So I will say x minus minus. Similarly, I will do for y. Similarly, I will do for y, and I will say y plus plus. Y plus plus. Now we have the number in the leftmost pass and the rightmost pass. We have to check the nearest one. Check the nearest one, right? So I will say I will initialize two if statement that if current dot val minus x is, let's say, greater than y minus current dot val, like value. So that means that the distance from the x to current value is greater than the y to current value, right? So I will say that the nearest should be my answer. So I will say that current dot val is equals to y. In all the rest of the cases, which will handle the inequality of, it handles the inequality of what less than equals to, right? We have to update it with the smaller one. So I will say current dot val is equals to x. So I hope you are getting this point up till here, right? So now what I can do that I will say I'll just have to move ahead current equals to current dot next, and everything seems fine to me now. So let us hit compile and run to check that our code and the logic are on the same page or not. Okay, so there is something wrong. So I have to mention y here, and let us compile and run again. So there's a missing return statement. So where I have, okay, so at last I have to return the head pointer as well, right? So I will say return head. Yeah, I think we are good to go now. Let's check it again, and then we will see that what other optimization can be made. So great. So our output and expected output matches, and as we already discussed, the time complexity of this solution is n into k into square root of n, right? Which is nothing but if we ignore the constants, it will be n into root n, and the space complexity will be O of 1, right? And the max complexity according to the constraint we can use is n square, right? So n root n will definitely get submitted if I hit the submit button. So let us verify that, and we will move ahead with the other optimization. So it is taking a lot of time to test case to be processed, right? So as you can see, this approach finally got submitted, right? So the 10 per 8 logic always holds here. So if you have not still watched that video of time complexity, that how this 10 per 8 is coming into the game, because this constraint is a very good point of starting the question. Whenever you read a question, see the constraint and then think in a particular direction, right? Because that will help you in the competitive coding as well. So okay, visit that video and come back again. So what should be the optimization? Let me give you a hint, and then you must pause the video and try to think of the solution yourself. So whenever the prime numbers are in play, right? Okay, so let us come again with this point that whenever the optimization is made into our current code, then we always see then what is the recurring part, what is that step that we are making again and again in this code. Then from that point only we can eliminate that step, and we can introduce some initialization in our existing code, right? So what can I see that I am checking for each and every x, for each and every y, that is it that it is prime or not, and I'm wasting my under root of n complexity for each and every value, right? So if I'm able to come up with a logic that I can check if it is a number, if a number is prime or not in O of 1, then our code will like execute it in just for loop, because we eventually need to check that prime number, it is a prime number or not, right? So you have to eliminate that step. But you have to shorten that step. You have to do that step more smartly, right? Because you need the results for line 63 and 65. You need the results. So try to think of a solution where you can check the prime number in O of 1 or not. And if you're aware with this, if you have spent good time in studying data structures and algorithm, you must be knowing an algorithm must be clicking to your mind. So I highly encourage you to pause this video and then think of a solution that how you can write it, and then resume the video, right? Okay, so I hope you guys were able to figure out the solution, and if not, then the algorithm, let me give you the name now. The second hint is that you have to use the algorithm of Sieve of Eratosthenes, if I'm not pronunciating it wrong, right? The Sieve algorithm of, let's say, Sieve algorithm, right? So now go research on it and try to understand it yourself, and if not able to understand, come back to the video again. So, okay, so let us resume the video again. So how the Sieve algorithm works is that you need to do some pre-processing. How that pre-processing works is that, let's say you have a number from, let's say, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So what Sieve says that initially mark everything as true. That I'm saying that each and every number is a prime number, right? And let's start iterating by using a for loop, right? What it says that start from I equals to 2 and go for I star I less than equals to 1, the same case, right? And I plus plus. Because why you are using I star I? Because for a particular number, if the factor exists, then we can always say that that one factor, we can get any one factor in the range of 0 to root of n, right? Similarly, I showed you for this example 6, right? Similarly, we run the for loop here, and then what we say that if s prime is true, right? For this, let me write it for you. If s prime is true, so you can see for 2 it is actually true, and it is actually a prime number, right? But 2 is a prime number, and you can clearly say that multiples of 2 will not be a prime number, right? So you can say that 4 will be false, you can say that 6 will be also be false, and 8 will also be false, and 10 will also be false, right? So using a number which is a prime number, you are marking its multiple as false. That is the intuition of the Sieve algorithm, and that is the pseudocode I will write for you guys. So I will say for j is equals to I star I, I'm moving in the multiples of 2 now, right? And I will say that j should be less than equals to n, that is n is nothing but n equals to 10 here, that we do not go out of the bounds of the array, right? And what can I say is j should move in the multiples of 2, right? So I will say that j plus equals to I. First j was equals to 2, then I did 2 plus 2, that means j becomes 4, and then j becomes 6. Similarly 8 and 10, I'm marking it as false. To mark it false, you can just say that s prime of j is equals to false, right? Similarly, you will go to the point 3 and you will say that the tree is true, and it is actually true, right? But the multiples of 3 would be false, right? So similarly, you will convert this statement. So right. So first of all, the square root of 10 will be 3. Yeah, 3. So it will move. So it will the for loop will run from 2 to 3, right? Okay. So the 3 is true, and it will mark the 6 as false, which is false again, but it will mark the 9 as also as false. And as you can see, the rest of the numbers existing as true is actually a prime number starting from the second index, not from the 0 and 1, right? So if you can see the 2, 3 true is actually a prime, 5 is also true, it is actually a prime, 7 is also true, it is actually a prime number. And the time complexity of this code is O of log, log n. It may seem like you O of n square, but it's actually not. It is O log n. So there is a mathematical derivation behind this time complexity. So if you are interested more to deep dive into it, then you are free to go research more and see that how this thing is coming as log n. So if you have completed your BTech here, maybe you have learned this thing as Fourier series, right? So the derivation is on this, but I will not encourage you to see how the time complexity getting right, because that is not entirely the motive. The interviewer also will not ask you this. I'm saying this as per my experience, right? Okay, so let us code this solution, and we will do the same things that we were doing, right? So what I will do is I will just remove this thing. I'll just remove this thing, and I will do a pre-processing. I will do a pre-processing here. So let me write it as pre-processing, right? And so let me make like write the Sieve code here, right? So let's not waste time in making the video large, and let me write the code. And in the meanwhile, I highly encourage you guys to write your code yourself for the Sieve algorithm, and then we'll see that what are the changes required in our main code, right? Okay, so I hope you guys were able to write the Sieve algorithm code, and I have explained it numerous times in my GFG POTD streak, right? So if you were with me with the day one, then you must have like memorized this concept of sieve thing, that whenever the prime number is coming, then just go for the sieve for the optimal solution, right? Because it gives you the privilege of accessing the if it is a prime number or not in O of one, right? So that's the code here. We will just make a is prime array, and the constraint for n for the value of node is from 1 to 10 power 4, right? So just for the safer case, I have made this n as 10 power 5, and we have made an is prime array for new Boolean size n. Then we have filled the each and every entry as true, assuming that every number is prime as of now, and then we have started our for loop from I equals to 2 to I star I less than n. And then if it is true, then you have to mark its multiple as false, right? Because that's a very obvious thing, that if 2 is a prime number, then a multiple of 2, that is 4, 6, 8, 10, will not be prime, right? That was the intuition. So for this, we have done this thing, and we are marking it as false. We are moving in the multiple of the number which is a prime. So I already give you the dry run, right? So we did this pre-processing, and now we will use this thing to in this our while loop, and we will get this thing in just O of 1. So I will say that if it is prime, so this will take now O of 1, right? Right. And and x minus minus, I already said that that would be a constant, like you would never have to check in terms of 10 power 4 to just check that if current node is prime, then you have to move 10 power 4 times to check in the left mode or right mode directions to find it, right? I already explained you that part. So it would be, again, the checking here will be O of 1. So now just have to replace it with the curly braces, sorry, the big brackets, right? And it will check it. So that is it. So let us compile and run and see if our solution works. So now the time complexity will be O of n, right? The overall time complexity will be actually n. The overall time complexity would be, why I'm not able to write here. It would be log n plus n, right? This would be time complexity, and space complexity will be O of since we have used an array, then you have to use you have given a space O of n. So that's a time space trade-off, as you can call. And let's hit the submit button, because the O of n is 10 power 4, nothing but less than 10 power 8, so it should be submitted. So let's me comment this line, and we'll hit the submit button here, and we'll see for ourselves. So again, the compiler is taking a lot of time. So I refresh the page, and you can see that the test cases are passed actually, right? And you can see, let me give you a code walkthrough again, that nothing, we have used the Seive algorithm pre-processing, that is a CI Seive algorithm, to check each and every prime number is in O of 1 or not. Right, so let us discuss the summary, and then we will end this video. So the summary would be, let me write it here. The summary would be, the first step we said, we see that it would be O of n into k into root n, right? K was nothing but to move in x minus minus or y minus minus, right? Okay. So it would be like nk root n is nothing but O of n root n, and the space complexity was O of 1. We did not use any space. The second time you see that there was a prime number, so use the Seive algo. The most optimal way to play with the prime numbers is the Seive algorithm. So we use the Seive algorithm, and then the code changes to O of log n plus n. But if we ignore the lower bound and talk in just one bound, then it will be O of 1, and space complexity will be O of n, since we use the array boolean array to show the sieve. right? That is it for today's video. And if you like my content, because I really mm, dedicate the whole time and energy and patience to just make you guys understand, as well as it's making my understanding growing as well. So let us grow together in our coming journey for ahead. And few last thing, that's my DSA channel, DSA page, DSA repository. You can start and fork to get the source code, as well as you can connect me on Instagram. It's a public account, as well as on LinkedIn, as well as on the comment section if you have any doubts or guidance if you may want. And that's it. And I'm also making an SD sheet. You can refer to this sheet. I have started the sheet from the advanced topics, that is recursion, graph, trees, and DP. So I have completed my recursion playlist, and I have updated the links as well as the problem if exist on GFG or on lead code, right? And I have explained the ways how you can solve it, all the recursion tree, because that's the thing we always used to stuck in this advanced topics, right? So that is it for today. And let us meet tomorrow in our next week of day 115. Till then, bye bye, take care, keep learning, keep growing, and bye bye.